Utilizing proven techniques and manufacturing methods, Extreme Components has designed and created the most effective injection molding alignment locks in the world that provide durability, reliability, and precision in a simple, inexpensive, cost-saving device. The Dynamic Alignment Technology, or DAT, developed by Extreme Components, is a revolutionary method for self-aligning locks that exhibit minimal friction and wear, even at high speeds. The technology uses rollers instead of metal-to-metal frictional surfaces to align the tongue. The rollers are constrained in a cage so that they move in a prescribed manner due to the kinematic relationships between the rollers. As the tongue is inserted into the housing, the first set of rollers is extended outwards so that the tongue clears the first set of rollers. Since all the rollers are geometrically constrained by the surrounding cage, the movement of the second set of rollers causes all the rollers to move simultaneously, including the first set. The first set is initially positioned on a fillet near the outside edge. Since they are geometrically constrained to move with the second set, the first roller effectively climbs the fillet and dynamically clamps the tongue, forcing dynamic alignment between the tongue and the housing. A significant spacing between the first set and second set of rollers provides a large moment arm so that the rollers can apply a torque on the tongue that forces alignment without exhibiting an excessively large force on the rollers, which would otherwise cause mechanical wear. In addition, the rollers provide a kinematic mechanism in which the tongue can be moved relative to the housing without direct mechanical contact between the tongue and the housing. This minimizes friction and therefore substantially decreases wear. Surface roughness analysis performed by Q+ Labs confirms the minimal wear experienced by Extreme Components DAT locks. Using a Cyber Technologies CT300 white light profilometer, the unused surface of a friction lock was found to have an average roughness of 10.6 microinches. The surface plot shown indicates green being a level surface, while yellow and black areas represent hills and valleys, respectively. As we can see, there is major deviation from the level surface, while the actual tongue contact surface was too rough to measure and galling is observed from visual inspection. In comparison, the tongue contact surface of an Extreme Components DAT lock that had been used by a multinational medical device manufacturer for 4 years of near continuous service, cycling every 7 seconds with a 2,300-pound load yielding more than 10 million cycles, was measured to have an average roughness of only 5.7 microinches. The surface map shown displays better uniformity than the antiquated friction fit lock, while visual inspection of the measured lock shows a mirror-like surface and no galling. This confirms that DAT locks maintain the highest degree of precision for the most sensitive of applications even after tremendous use. Even when new, outdated friction fit locks can't compete with the DAT lock's level of performance. The kinematics of the DAT locks results in a number of benefits over friction fit locks, including a reduction of friction, vibrations, heat, and wear, lower maintenance costs and longer lifetime, better reliability and precision, and a smaller profile for the same mechanical load. This translates to lower manufacturing costs by reducing machine downtime, increasing manufacturing speed, decreasing the amount of flash created, and maintaining part tolerances down to 0.2 after more than 10 million cycles. Now that we have demonstrated how Extreme Components locks utilizing DAT work and evaluated some of the cost-performance benefits, let's briefly examine why this device became necessary. As we all know, there have been enormous advances in injection mold manufacturing. CAD/CAM makes it possible to achieve very complex geometries while holding a tolerance of 0.2. Lead times have been compressed, and there's been an increase in competitiveness from low-cost countries. All the while, the tool builders expected to guarantee mold performance of 1 to 5 million shots, something unheard of 20 years ago. Recognizing that leader pins and existing alignment devices were inadequate even when new out of the box, we laid a plan to develop a better product. The first step in a process like this is to identify the culprit. In this case, friction, which leads to other factors such as thermal expansion, vibration, and wear of mechanical parts on the press and mold itself. What was needed was a device that could not fall out of adjustment, required no batteries, limit switches, or any human intervention besides general maintenance requirements that would be the same as the mold itself, since unscheduled maintenance due to premature wear can be very costly for manufacturers. It must also accommodate pockets machined into existing molds and conform to standard mold designs. From our research, we know that even in a new press, the platen will not repeat to an exact position every cycle because of the accumulation of errors on the many components of the press and required tolerances of things like tie bars, bushings, hardened ways, and toggles, to name a few. Most importantly, this device had to make all required corrections of the dynamic side of the tool and the platen every cycle and could not wear over time. To do this, it had to apply exact equal and opposite forces to get the same final result, regardless of press conditions or human error, and all but eliminate friction. We found the answer in our own CNC machines, more specifically the needle bearings and hardened ways that are used for guidance and precision. These machines can take enormous loads with constantly changing conditions of speed, direction, and temperature, as well as changing machining requirements such as roughing or finishing, and always produce the same results even over extended periods of time. In observing these proven techniques and taking into consideration the required change of conditions of injection molding, we developed a lock with dynamic alignment technology, the highest precision and longest lasting device of its kind in the world. Our stock consists of a full range of sizes and styles to accommodate nearly 95% of tools, and customs are available upon request. Currently under development is a first-of-its-kind calculator to make selection of a particular device easier and more precise. For more information on Extreme Components DAT locks and to contact a sales representative, visit xcomps.com.